Okay, so let's review real quick. So 97 through 104. We're going to finish a review that we started yesterday. So question number 97. Okay, let's take a look. We're going to factor each completely. Now, it would be nice if it started with a 1, right? Because it's a little bit easier. But now this one, because my first number is not a 1, first thing I ask myself is, can I make it a 1? Can I divide everything by 6? First thing I ask myself, can I divide everything by 6? No, I can't. Okay, so I have to deal with it. So what I'm going to do, I'm gonna do my X thing. People call it diamond sometimes. I'm looking at two numbers such that when I add them, it's gonna equal to -7. You guys see where that -7 comes from. So there's two numbers that when I add them is equal to -7, but when I multiply them, it's gonna equal to a -294. Okay, now the 294, I multiply these two. 6 times -49. That's where I got the -294. So I'm looking for two numbers that multiplied equals -294, but when I add them, it's equal to -7. All right, because in multiplication, they equal negative. So I know when I'm dealing with a positive and a negative. I know when I'm adding a positive and negative, basically I subtract the value. So all right, so I'm looking for two numbers that multiplied equals 294, but when I subtract them is 7. All right, so let's think of the multiplications of 294, all the factors of 294. I'm gonna go 1 times 294. I'm gonna go 2 times 147. All right. Now, one thing, how did I get the 147? I really went 294 divided by 2. Okay. I did the division backwards. 294 divided by 2. That's how I got that 147. Now, 3, let me see. 294 divided by 3 gives me a decimal. Okay, so 3 is not a factor. Divided by 4 and divided by 5 give me decimal as well. So they don't work. Now, by 6. 294 divided by 6 gives me 49. Okay, so 6 times 49 is 294, but when I subtract this, 49 minus 6, nope, I don't get a 7, so I gotta continue. 7, 7 times 42. Again, I just went 294 divided by 7. That's how I really did it. Okay, 7 times 42 gives me 294, but do not give me the 7 when I subtract. So I have to continue. After 7, notice how my list on the left, I keep on increasing. 1, 2. I tried 3, 4, 5. They didn't work. Then I have 6, 7. I tried 8, 9, 10, 11, 12, 13. They don't work. But then I have 14 times 21. Okay, 14 times 21 gives me 294. When I subtract this, gives me 7. So that's where I'm going to stop. So it's positive 14, negative 21, right? The bigger number has to be negative. So nice. Now I found how to split the middle term. Because my first number is not a 1, I'm going to go straight to parentheses. And like if it was a number 1, I mean, if it was a 1 to begin with, I will go straight to parentheses. Because my first number is not a 1, I'm just going to split my middle term. So my first term, 6x to the 4th, is just 6x to the 4th. My middle term, negative 7x squared, I'm going to break that as positive 14x squared minus 21x squared. Notice how I split, right? 14 minus 21 is -7. So my middle term, I split it into two terms, and then my minus 49. Again, my middle term, I split it. I wanted to make this a group, a factor of 4, because I know when I have 4 terms, I do grouping. So I'm looking at my first 2 terms only. 6 and 14, I can divide each by 2. And then x squared. I go by the smallest exponent. So number wise, when I do my division, my distributive property backwards, Number-wise, divide everything by 2. Letter-wise, subtract 2 from each exponent. So it's going to give me 3x squared plus 7. Okay, each number divide by 2. Each exponent subtract 2. Okay, now when I look at the last two terms, negative 21 and a negative 49, I can divide each by a negative 7. I'm not going to be able to factor out an x because my last term doesn't have an x. So I'm just going to divide each numbered by a negative 7. So it's going to give me 3x squared plus 7. My parentheses have to be identical. So I'm going to go 3x squared plus 7. And the other parentheses, 2x squared minus 7. That's basically what I have here. When you type in your answer, it doesn't matter which parentheses comes first. Now, for 98, we can do it the long way, right? K squared plus 0k minus 25. I added the 0k at the beginning, so I see it in a trinomial, and then I'm looking for two numbers that multiplied are equal to negative 25. When I add them is equal to 0, right? We can do that. The diamond method will work. Another thing I showed you how to do this, I call it the difference of the squares. When it comes to special cases, the difference of the squares. Now, in order for this to be difference of the squares, I have to have a minus, and then before and after the minus, everything to the squared. So k squared, I can easily write it as k squared. 25, I'm going to write that as 5 squared. It has to be a minus in between, and then before and after the minus, everything to the square. That's what we call it, the difference of the squares. Now, one of my parentheses, because this is a special case, I talked about it last week, k squared minus 5 squared, one of my parentheses will be k plus 5, and the other one is going to be k minus 5. So one of them has a plus, the other one has a minus. We can do the long way. We can do the diamond method, but we can just go with the short version. Now, 99, I can do the long way. I can be thinking, all right, two numbers that when I add them are equal to 24, and when I multiply them are equal to 144, right? 9 times 16, it's going to give me how to split the middle term. But I showed you, first of all, let me check if this is a special case. I talk about special cases. I came in and said, special cases, let's get the square root of the beginning, get the square root of the end. The square root of 9x squared is going to be 3x, right? The square root of 9 is 3. The square root of x squared is x. At the end, the square root of 16, that's 4. If I multiply these two, 3x times 4, and it is equal to half of the middle term, right? 3x times 4 is 12x, which is the half of 24x. So again, if I multiply these and it's equal to half of the middle term, I have a special case. Because my middle term has a plus sign, I'm going to respect the sign. My special case, it means that this parentheses, 3x plus 4, I'm going to have it twice. So when I type my answer, I'm going to write 3x plus 4. Oops, forgot the plus sign. 3x plus 4 inside the first parentheses, and 3x plus 4 inside the other parentheses. I'm literally going to write 3x plus 4 twice. Again, if we do the long division, right, I split this as 12 and 12. I'm going to split my middle term. You guys are going to find out you guys get 3x plus 4 twice. Again, I tried it if it's a special case to begin with. Now, question number 100, there's two terms, but I see my exponent is to the third. So I'm going to say it would be nice if I could write everything to the third, but in this case, I cannot. But I'm like, say, well, what if I divide everything by 3 to begin with? So that's going to give me 1 plus 216 a to the third. I think that inside of the parentheses now, I can write it as everything to the third. So I have a 3 on the outside, right? I can write this as 1 to the third plus 6 to the third, 8 to the third. I was able to write everything to the third. Okay, so my answer is going to be easy now. So there's a 3 at the beginning. My first parentheses, let me write 1 plus 6a. Remember, I talk about difference in sum of the cubes. Remember that? That's a reminder of the lecture we covered. Okay, so 1 plus 6a. My second parentheses, right? This one starts with a 1. Square it. What's 1 times 1? 1. The end of my parentheses, see how this one finishes with 6a? Square it. What's 6a times 6a? So I'm going to write this as plus 36a squared. Now the sign in the middle, the term in the middle, first I look at this sign, plus. So I'm going to switch it to minus. Got to switch it. And then I multiply these two terms, 1 times 6a. And my answer in there is going to be 6a. So there, that's how I factored. 3 times 1 plus 6a times 1 minus 6a plus 36a squared. All right, then simplify the imaginary numbers, no exponents. Okay, so gotta do this real quick. Now my we talk about this at the beginning of the week, right? If you guys go back on your notes, question number 72, I need my exponents to be I to the 1, to the 2, to the 3, or to the 4. I need my exponent to be to the 4th. So I'm going to subtract any multiples of 4. To begin with, let me subtract 300. Because any 100, like 100, 200, 300, any 100 is a multiple of 4. So I'm going to subtract the hundreds just to make this easier. So it gives me I to the 24th. Right? Get rid of the hundreds. If it's a negative, add hundreds. Like I'm going to subtract multiples of 4. Then let me subtract any number multiple of 4. Some of you guys can be like, can I subtract 4? Okay, that gives you I to the 20. Can you subtract 4 more? Go for it. In this case, let me subtract 16th, right? Any multiples of 4. That gives me I to the 4th. I wanted my last exponent to be to the 1, to the 2, to the 3, or to the 4th. Now, I know on question number 72 from our notes, I simplify everything, right? I to the 4th simplifies to just 1. My answer will have no exponents. So you see how I even emphasize on the instructions, no exponents. Okay. Then we talk about radicals. Remember how to do the radicals here. So now let me simplify this real quick. So I'm going to go -1. I'm going to factor a -1. And then 32, I'm going to break this. So I notice how I factor the negative sign. I'm going to think of two numbers multiplied are equal to 32. But one of my numbers has to be a perfect square. As a reminder of my perfect squares, 4, 9, 16, 25, right? Perfect squares, you guys know those. So let me start with 4 times 8. I think square root of 8, we can do better. Right, this one, let me split it as two terms. Let me go 4 times 2. Because the square root of 1 is I. The square root of 4 is 2. The square root of 4 is 2, and then I still have a radical. Now, when you multiplied everything that came out, it's going to be 4i, and then radical 2. All right, some of you may be like, Mr. Lorenzo, how do I type that out? we're going to go 4I, RAD for radical, and then inside parentheses 2. 4I radical 2. Okay? Don't forget the parentheses, the 2 inside parentheses, because there's a 2 inside the radical. So we use RAD for radical. Okay. Another thing we talk about with imaginary numbers was how to combine them. So let me write everything without parentheses. So first I'm going to go 8 minus 6. Because of this minus before the parentheses, I'm going to change the sign on every term inside the parentheses. So let me write this as a minus 5 plus 3I. Again, I changed the signs. Now that I don't have parentheses, let me combine the real numbers first. 8 minus 6 minus 5. Isn't that negative 3? And then let me combine that i's, the imaginary numbers, plus 3I. When you combine imaginary and real numbers, we call those complex. Make sure you combine the real numbers first. So negative 3 plus 3I. Another thing that we learned how to multiply these. So let me use red for work. Let me distribute the negative 4 to the second parentheses. That's going to give me negative 16 minus 12I. All right, now let me distribute the 3I to the second parentheses. That's going to give me plus 12I plus 9I to the second. Now, 9I squared, that's basically minus 9, because I to the second is negative 1. So that's what makes us change the sign. All right, let me combine my real numbers first. Negative 16 minus 9, that gives me negative 25. Now at the imaginary part, negative 12 plus 12, that's 0. They just basically cancel out. There you go.